session is called Mastering STEM Research from Failure to Success, because real science is rarely a straight line. It is messy, nonlinear, and full of surprises, and that is actually a good thing. So at most fairs and competitions, many projects look impressive at first glance, but only a few students can clearly explain what their results mean and how they learn from what didn't work. Those are the students, and keep it in mind that judges remember and colleges notice. So today, we are going to focus on 3 big skills: how to analyze failure without freaking out, how to interpret your results like a scientist, and how to present and defend your research with confidence. So next slide, please. So let us start with something most students secretly worry about: failure. The first step is to reframe your mindset. Failure in research is not a personal flaw. It is a signal that tells you something about your design, your assumptions, or your tools. And every great discovery you have heard of has a long trail of things that didn't work behind it. When something goes wrong, keep it in mind as critical questions instead of panicking. For example, was my experiment set up the way I planned? That's one of the questions that are important to have in mind. Did I really control the variables I said about, or could there have been errors in how I collected or recorded that data? So this is where documentation matters. A good lab notebook is your best friend. Write down what you did, what you expected, what actually happened, and any weird observations. That way you can go back and detect patterns instead of relying on memory. So keeping notes is very important when you're doing research. Think about Thomas Edison. He tested over 1,000 different materials for the light bulb filament, and each failure wasn't a waste. It actually taught him something specific. This material does not behave the way I need it to, all right? So that is also a key outcome from trying so many times. So when your experiment doesn't work as planned, don't label it as bad, as what exactly information is this giving me? The question alone puts you ahead of most students. And this brings us to a key mindset shift. Results are not good or bad.